Hello students, this is Dr. P. Lakshmi Prasanna. I am the lecturer in Social Welfare Degree College, Shamirpet. Today we are discussing about generating functions. So we have the four generating functions: moment generating function, probability generating function, characteristic function, cumulant generating function. Now the topic is about probability generating function. So what is the purpose of probability generating function? This purpose only for discrete distribution of the random variables. Okay. This distributions about through we have to find the moments only. For all discrete distributions we have to find the through moments, first moment and second moment of the central and non-central. What is first moment? Nothing but that is the mu1 prime, that is the non-central moment, and mu2 nothing but second moment, second central moment only. So through moment purpose we are using this generating functions for all discrete distributions. Okay. So see here, probability generating function is understanding for the discrete probability distributions. So this is about introduction about probability generating function. So PGF is used for discrete random variables only, and it is encodes probabilities into a power series. Why power series? This is formula is related to Px of s equal to expected value of s power x, means here showing the power. So that is why that probability is into a power series, and it is important in probability theory and statistics. This is generating function. So this is the definition of the probability generating function. For a discrete random variable x, Px of s equal to expected value of s power x, power, it showing the power series function where mod s is less than or equal to 1. And here that formula expanded for the discrete distribution purpose and probability distribution function. How can we represent the probability distribution function? So generally what is the in probability distribution function, how can we represent in the discrete case? P of x, expected value of x equal to summation that function into p of x only. Yes, same thing according to our probability generating function we are representing the probability distribution function. How can we write probability in mass function? So that is expected value of p of x of s equal to summation that function into expected value of sx equal to into p of x only. Okay. So this is the expansion of the probability generating function in the probability mass function. It the formula. And probability generating function, why probability generating function? Because it generates the probabilities and moments, and it is easy to simple and easy to understand, and it is easy to calculate in everywhere. And this is purpose only for probability distribution purpose we are using this probability generating function. So these are the properties of the probability generating function. So what are the probability generating function properties? First one is P of 1, probability of the any constant term equal to constant only. Suppose P of 2, that is equal to 2 only. So like that. And coefficients represents the probabilities only, and it is helps in computation of the moments only, and it is useful in some of the variables. Some of the variables nothing but, suppose if x plus y is there, that is the two variables, sum of the two variables, that is equal to sum the product of the individual variables. Addition follows product here. So that is the one of the property of the generating functions. And here we are taking in some discrete distributions. We have many distributions are there in discrete series. What are the distributions? Bernoulli distribution, binomial distribution, Poisson distribution, geometric distribution, hypergeometric distribution. Okay, these are all discrete probability distributions. So in probability generating function, its purpose is only for discrete distribution purpose only we are using. Okay, so one first distribution we are taking, that is Bernoulli. So what is Bernoulli distribution of the probability mass function? That is P of x equal to 1 minus p power 1 minus x only. Here what is that p? P is the one of the parameter of the Bernoulli distribution only. Actually in probability distribution of the Bernoulli distribution is follows only two conditions, that is one probability of success and one of the probability of the failure. Success is nothing but p and failure is nothing but q. So according to that, here we wrote the one notation, that is what, if p of x equal to 1 equal to p and p of x equal to 0 equal to 1 minus p, or in 0 representation we can represent in another way also. What is 1 minus p? 1 minus p is also q. Okay, because p plus q equal to 1. So q representation is 1 minus p, p representation is 1 minus q. So like that. So after applying this probability mass function of the Bernoulli, what is the probability generating function? That is 1 minus p plus p of s. Okay, and similarly we are taking another distribution. What is that? Binomial distribution. What is the binomial distribution of the probability mass function? That is ncx p power x q power n minus x. Here the parameters are n and p are the two parameters of the binomial distribution. Okay, so here also we are using this probability mass function through PGF. Then we will getting this expansion, that is px of s equal to 1 minus p plus p of s whole power n. After solving this, we are getting this binomial distribution of this function. And again we are taking another distribution of the one of the discrete, that is Poisson. What is Poisson distribution probability mass function? That is e power minus lambda, lambda power x by x factorial. Okay, here also one of the parameter only lambda only. So that is the lambda is the one of the parameter. So after applying this generating function through this probability mass function, we are getting e power lambda into s minus 1. Okay, geometric distribution. This is the one of the discrete distribution. In this geometric distribution, parameter is the p. So what is the probability mass function of the geometric distribution? P into q power x. Okay, so here we have to apply this probability mass function. We will get the probability generating function of the geometric distribution is ps by 1 minus qs, q nothing but 1 minus p. And through finding mean and variance, finding EGF, what we will get? Mean is expected value of x equal to p dash of 1. Okay, and variance, variance of x also. So how can you find the variance? What is the formula in expectations? Expected value of x square minus expected value of x whole square. Okay, through moments how can we find this variance? Mu2 prime minus mu1 prime whole square. Okay, through using moments only we are finding this probability generating function. So these are the applications of the probability generating function, where we are applying in queuing theory, branching process, reliability analysis and statistical modeling. So these are the some of the applications in PGF. So these are the advantages. Some of the advantages are, it is very simple and easy to calculate, and it is also for discrete purpose we are using this probability generating function, and mean and variance purpose we have to find the through mean and variance we have to use this functions, and limitations only for non-negative integer variables only. And after concluding this probability generating function, what it is? It is a powerful tool in probability. Okay, for discrete purpose we are using this probability generating function, and it is also help in discrete distributions only, that is probability distribution functions, and it is also used in all statistical applications. Okay, this is about only for probability generating function. And now we are discussing about another generating function is one of the important generating function is characteristic function. So, what is the characteristic function? This is a characteristic function is pi x of t equal to expected value of e power I t x. It is also same movement generating function only. In movement generating function we are using mx of t equal to expected value of e power t x only, but here we are using I, that is we are using I t. So, that is the in place of t we are applying here I t only, that is characteristic function, that is complex theory we are applying in characteristic function. See here, a characteristic function uniquely describes the probability distribution of a random variable. It is used in probability theory, statistics and signal processing, and this characteristic function is closely related to Fourier transform of a probability distributions. And these are the some characteristic function of the properties. What is that? Phi of x comma 0 equal to 1. So, that x0 equal to constant only. Characteristic function is always exist in everywhere, and it is uniquely determines a distributions, and x and y are independent, and it is uniformly continuous, and this is relation with the moment generating function of the characteristic function. So, these moments can be obtained using the derivatives only. Okay. And these are the applications of the characteristic function. So, where we are applying this characteristic function in probability theory, statistical inference and signal processing, branching process, so financial mathematics, queuing theory. So, in we are using this characteristic function. So, important uses are given. See, finding distribution of the sums and proving the limiting theorems and solving the differential equations. So, what are the advantages of the characteristic functions? It is exists for every random variable, and it is simply easy to calculate, okay, and it is easy to understand also, and it is also identifying the distributions uniquely, and it is useful in theoretical proofs also, okay. It is also handling in independently different random variables also. So, these are the limitations of the CF. So, what are the limitations? This is complex valued function can be difficult to interpret, because our function is what it is, it look like a pi x of t equal to expected value of e power I t x, that is complex valued, that is inversion process also may be complicated in these limitations, and it is requires the knowledge of the complex analysis. Yes, we are here we are using that function IT function, okay. So, these are the some comparison with the moment generating function and characteristic function, okay. What is always exist where in characteristic function S and MGF is not always, in some cases it is not possible for the moment generating function. For complex numbers, yes, because here IT function we are using in the characteristic function. So, here complex numbers are useful in characteristic function, not in moment generating function, and uniquely we have to determine the distributions, yes, in characteristic function and the moment generating function. So, in everywhere, suppose if you are finding in moment generating function, obviously we will get the characteristic function, because just in place of t we are writing in IT only in characteristic function. So, suppose if binomial is possible for MGF and CF also possible for binomial, if Poisson is possible for MGF and Poisson is also possible for CF. So, if MGF is possible for the any distribution and characteristic function is also possible for in every distributions, okay. So, main use in theoretical analysis, we are using characteristic function. Here we are finding for the finding moments for the moment generating functions. CF is more general than the MGF only. So, these are all generating functions we are applying for the movement purpose and for all the discrete distributions only, for binomial distribution, Poisson distribution, geometric distribution, hypergeometric distribution. So, like that we are applying these generating functions. Actually, final, what is the purpose of generating functions? Finally, we are using the purpose of the generating functions is all discrete type of distributions and through the finding the moments also, that is the first moment and the second moment, the first non-central moment and second central moment. What is first non-central moment? That is only mean. What is second central moment? That is only for the variance. Okay, through moment purpose and through distribution purpose we are using these generating functions. So, this is summary about the characteristic function. So, what is the characteristic function? It is the Fourier transform based representation of the distribution, and it is uniquely identifies the all probability distribution. In Poisson we are applying and binomial we are applying, hypergeometric is not applying for because in some distributions only we are applying, this is the distributions only. So, in some cases only it is possible to find the generating functions, in not all cases. Okay. And it is useful in studying the sum of the independent variables and limit theorems also. It is important tool in advanced statistics and probability. In every probability theory we are applying these type of distributions and these type of generating functions. These generating functions are helpful in everywhere, in all application point of view. In queuing theory we are applying and branching process and financial mathematics. So, in all fields we are applying these generating functions. So, these 4 types of generating functions, this is similar to MGF is similar to this characteristic function, and PGF probability generating function, and cumulant generating function, and this MGF is also similar to this cumulant generating function also, because in MGF only mx of t equal to expected value of e power tx. What about cumulant generating function? This here we are applying the log of mx of t, that is equal to kx of t. So, there is a relation in between MGF and cumulant generating function. And what about characteristic function? Here we are same we are applying the formula, that is but in place of t we are applying in characteristic function it. So, there is a relation with remaining generating functions through MGF only. MGF is related to cumulant generating function, MGF is related to characteristic function only, and probability generating function is that is different to all generating function, that is purpose only for discrete distributions only. Okay. And this is that purpose is only for the through moments, first moment and the second moment. So, these are all the generating functions are helpful in finding the probability distribution functions and through moments also. This is about the all generating functions. Why we are using this probability generating function? Actually, this probability generating function is purpose is for the discrete probability distributions only. In discrete series we are using this probability generating functions. Actually, this probability generating function purpose is only for through finding the moments also. So, what are the moments? Moments nothing but first moment and second moment. So, what is that first moment? That is expected value of x equal to mu 1 prime equal to this mean equal to. So, this is nothing but the first moment, the first derivation of the second central moment is nothing but mu 2. So, this is also central moment we are finding through expectation also. So, through moment purpose we are using this generating functions. This generating function is particularly useful for the discrete distributions only. So, for example, we are using in Bernoulli distribution, binomial distribution, Poisson distribution, geometric distribution. So, what is the Bernoulli distribution? through we are using this here, two cases are there. So, why we are Bernoulli distribution we are using, that is the probability of success and probability of failure. It is based on the probability of success and probability of failure only. So, that means how can we write probability of x equal to 1, that is nothing but what, that is the p only, okay. And what is probability of x equal to 0, that is q, that is nothing but failure, okay. So, probability of success and failure in between, that is the two cases are applying, that is the Bernoulli distribution, success and failure, okay. And this is the about the Bernoulli distribution. So, in that we are, this is one of the example of the Bernoulli. And what about binomial? This is the n terms of the Bernoulli trials, that is nothing but binomial distribution. So, n number of trials, Bernoulli trials only, binomial where it is coming from, the Bernoulli trials only we are using this binomial distribution. So, what is that probability mass function of the binomial distribution, that is NCX p power x and q power n minus x, okay. This is only for the binomial distribution. Here for probability generating function, purpose is only for discrete distributions only, okay. Here also what are the parameters of the probability generating function of this binomial distribution, n and p are the two parameters only. So, what is that parameters? Parameters nothing but statistical constants only, that is nothing but parameters, okay. And next we have to use this Poisson distribution also, we are using this probability generating function. Here also only single parameter only. So, what is that single parameter? That is only for lambda only. So, what is that probability mass function of the Poisson distribution? E power minus lambda, lambda power x by x factorial only, okay. This is only for the Poisson distribution. This Poisson distribution purpose is also only for finding the moments only, okay. In every distribution we are using this probability generating functions, okay. That is why useful for studying the distributions only. So, okay. And next geometric distribution. So, what is the geometric distribution? Here also only one parameter, that is p. So, what is the geometric distribution of the this probability mass function? P into q power x. So, here also p is the one of the parameter. So, these are all distributions, discrete distributions are very helpful in the finding the probability generating function. So, this probability generating function purpose is only for through moments also, moments nothing but first moment and the second moment, okay. So, the first moment purpose is only for the derivation of the power series of the different type of the terms. So, this is helpful in every field also. So, these are the applications, we suppose if we are discussing this about this applications, we are applying in queuing theory, branching process, financial mathematics, statistical inference. So, in this applications we are applying this in different fields, okay. It helpful in every field also. And coming to in mathematical expectations, in AI also we are applying this probability generating function. Actually, probability generating function is helpful for the probability distributions functions. How can we write the probability distribution? So, this is in the probability mass function, in discrete case we have to apply the summation and the term into p of x terms we are applying. So, these distributions are helpful in one of the next another distributions also. Coming to another distribution, that is helpful in all distributions of the every distribution. This probability generating function is helpful in every field also. Actually, this is probability generating function, it is the power series term we are using. Actually, what is that formula? Px of s equal to s power x. So, the power Fourier transformation is applied in this this probability generating function. Okay. So, we have the different types of generating functions. We have probability generating function and cumulant generating function, characteristic function and moment generating function. So, applications are same. So, every field we are applying these generating functions, but some situations we have to, based on the situations we have to take the different type of generating functions. Okay, this moment generating function is related to this cumulant generating function, and moment generating function is related to characteristic function also, and this probability generating function, it is helpful in the all the discrete distributions only, and it is but these are all generating functions are helpful in through finding the moments and discrete distributions and continuous distributions also. In moment generating function is applicable for the continuous distribution also, and this probability generating function purpose is only for the only discrete distributions we are applying. Okay. This generates the only probabilities only, probability functions only. This is helpful in all discrete type of the distributions only, like Bernoulli distribution, binomial, Poisson, geometric, like that. Okay. In hypergeometric we are not applying, because hypergeometric have the different type of parameters, means they have the 3 parameters. Okay. So, single parameter and any 2 parameters, it is possible to find these generating functions only. So, this probability generating function is helpful in only discrete type of distributions only. So, this remaining all our distributions is also helpful in discrete series and the continuous series also. In normal distribution we have to apply the moment generating function also. So, what about normal distribution? This is the one of the most important continuous distribution. So, in this also we are applying this moment generating function, but it is not possible for the probability generating function PGF. This is only for possible only for the moment generating function and characteristic functions only. So, in some cases they have the some limitations and they have the some conditions. So, that is why we are applying only some distributions and in some generating functions for the distributions only. So, according to that we finalized. So, probability generating function is applicable for discrete series, and remaining distributions we have to apply according to situation, we have to apply the discrete series and the continuous series also. Finally, what it is, this is the generating functions are helpful for the through moments and the describe the distributions only. Thank you.